So just to carry on, we have already cleared all this gyrator and such like that. So we only left with op-amp, voltmeter, and transconductors, and a little bit more calculating noise and such. So let's talk about op-amp, voltmeter, and ammeter. How do you connect it, such that you can let it be the voltmeter or the ammeter. So you have a this is what um I sourced from the video on the lecture. So it's I don't know whether is it right or wrong, but it feels a little weird for the explanation. I may be wrong now, okay? Because you have a voltage over here when you feed into this non-inverting side. Maybe you have a 5 volt. Based on the op-amp nature, this will has to be also 5 volts, right? So whatever thing that comes out from here will feed back to here, the 5 volts. So whatever thing that comes out to the voltmeter is actually 0 volt. So there will be no there will be no voltage sent to the voltmeter to measure, right? So yeah, you cannot do anything, right? So you cannot measure anything because there's no voltage to measure. So what I actually sourced from the internet is that you have a 5 volt over here. Maybe this is 1 volt. Okay, the resistance is 100 ohm now. Okay, the difference is, if you remember, why do we connect in terms of inverting? If you still remember from the last video, it's because of the R2 and the R1, right? It's purely R2 over R1, that's all. So it's frequency dependent, and then it is also very it it can actually measures the gain very accurately, because it's only R2 and R1 difference, that's all. Unlike the if you were to connect in terms of R2 over R1, right? If this is the non-inverting formula, right? So if you were to connect in this manner, you're gonna have a biasing 1 over here, a gain of 1 in this case to top off lah, okay? So in this case, in this case you have a 1 volt, and then you flush it into your 100 ohm, and then you enter into the inverting side, right? So you have a 1 volt over here. However, your non-inverting side is grounded, so it's a 0 volt. So in order to ensure your next round of your this pin is 0 volt also, right? So because this is the nature of the oil, you want to ensure that the negative and the positive are the same volts, right? So you feedback, and then you send that this is 0 volts. So wherever 1 volt will pass out from here and send to the voltmeter, and then you measure the voltage. So this is using this op amp, you can actually have a more accurate voltmeter in this case. So you can actually calculate, more easier. So if you want to, if let's say if your voltage is, let's say, very small, right? If your voltage is very small, maybe like 0.01 volt, and your voltmeter might not be able to capture it, what you're gonna do is actually to use a difference in R2 and R1. So maybe you can increase the R2 by 300. So you can you can amplify the voltage. So you can actually measure the voltage. So R2 and R1, so 3 over, so you amplify by 3 times of the initial voltage. Then you can measure more accurately in this case. So this is the op-amp voltmeter in this case. Alright, it's not using op-amp to become a voltmeter, but rather than using op-amp to ensure there is a cleaner buffered way of voltage coming out, so that you have a more clearer, a more accurate answer for voltage. Right, so this is a voltmeter. So as for ammeter, ammeter you connect in terms of the inverting side. Okay, so they always reference to ground with the non-inverting one. This is why I don't know why the lecture is being drawn that the input is actually connected to the positive side. So it may be correct, I don't know. So I don't know. So yeah. So so the current itself is connected into the inverting side. And then since this is also still um grounded, so you have a 0 volt over here. Right. And then you know that from the rule of the, if you remember our first rule of M, actually I deleted your shit. So the first rule of the op amp says that so there will be two rules if you remember. So the two rules are, so the first rule states that no current flows in or out the op amp. So this is why, as you can see, 0 ampere, because there will be, because due to the configuration inside of the op amp, you will not allow any current to flow inside it. So basically, because you don't want to spoil or damage the op amp inside. So in this case, the second rule for closed loop voltage has to be the same. So this is a closed loop, right? So ensuring that the negative and the plus sign are the same volt. So in this case, this is also 0 volt, right? So if you want to have a multimeter in this case, you want to measure. Hold on, should continue with the ammeter first, and then I can talk about how to connect ammeter and voltmeter together. It's quite straightforward. So since the current cannot flow into the op amp, the only path it can take is only to flow into the ammeter over here. So this is only the pathway for the current, because there is a roadblock. It says no to current. No current. Okay. So in this case, if you're able to connect your ammeter over here, you can actually have actually can connect to the current and to measure your current. Alright, so this is the thing that it is. So if you want to connect if you want a voltmeter and ammeter together, right? If you want to connect a op amp, so it is simply like this. Hold on. So I have a source. Okay, I have a source, a power source. Maybe it's a DC, right? I connect to the negative side, or the positive is grounded. Okay, and then I have a feedback system that feeds back to, so I have a resistors lah. Okay, this resistors, if you remember, it acts as a gain parameter, so that acts as a parameter to actually amplify whatever voltage. Okay, in order to so that your voltage can be seen more clearer lah, right? So this is actually the if you want to connect your voltmeter over here. So this whole system now that I'm drawing is actually the voltmeter. Okay, this system is actually, hey hi, this is actually the voltmeter. So once you have the accurate voltmeter already, right, you can actually send towards your ammeter. So ammeter is connected in this manner. So it's like a minus and a plus. And then this is also being connected grounded. And then you have a feedback system where you have an ammeter over here, right? And then this is the thing, right? And then in your feedback ground, maybe you have a resistors over here. So this is a multimeter. Maybe I should not draw that. Maybe I should draw. Right. So this is a voltmeter. Okay, this is a voltmeter. This is a ammeter. And then when you know your volt, you know your current, you can know your resistor. I may be wrong lah. I don't know what the fuck am I drawing. I just draw only voltmeter and ammeter. So voltmeter and ammeter. Right, this is ammeter. So why you connect voltmeter over here first is because you want a accurate amount of voltage. Right? So this passing through this voltmeter will have a good accurate amount of voltage because of this op amp, right? So after which, when you have a good amount of voltage, you know that it is also the correct amount of current flowing through also. So the current will flow in through here and then go to the ammeter. And then with these, and then you close up and becomes a circuit lah, right? So you have voltmeter and ammeter. So how do you have a multimeter? And multimeter wise, I think you need to do some binary and then you can calculate for the ohm. Nonetheless, I've been wrong. So this is how the ammeter and the voltmeters are being connected if you want to calculate current and voltage together at a one go circuit. So still I may be wrong, but this one is correct. Just a pure ammeter and a pure voltmeter is correct also. So yeah, hopefully I give you a good sense. And nonetheless, this circuit might be wrong. Okay, might be wrong. And then this circuit can be correct also, but I don't know the explanation for why it's being connected in this manner. So I'll leave you to think about it, and I'll go on to transconductance, and then we can go and calculate the noise. So see you.